Good afternoon.
Good afternoon.
Are we ready for a new chapter?
Not really.
I guess.
Yeah.
Ready
No.
or not?
No.
This is it, 3.1. This chapter 3 is about polynomials. Okay? I mean, we are going to talk more about polynomials when we go to the next section, but 3.1, we are dealing with quadratic functions. You have already have enough experience with quadratic functions. You have seen them a lot. You have modified them, sketched them, graphed them. We're going to just take a deeper look at their graphs, their more properties, and where we use them. Okay? So we start with first formal definition of quadratic, what quadratic means. I usually call this, because it's easier to keep it in mind, I call quadratic functions square functions. That helps me visualize what to look for in that function. What I'm looking for is a square term. This is a must. It has a square term. I call it square function. So what are the other two items? These are optional. They may sometimes disappear in the equation. But in most general form, you see three of them together. And your variables, as you see, is x. It's x here. So A, B, and C will be given as a number to you. So A, B, and C are unknowns right now. But they will be provided like sometimes A is 1, B is a negative or positive number, C is a negative or positive number. So these pluses may switch to minuses depending on the sign of B and C. But this is called the standard form in general. This form is called standard. But you know what I call it? I call it useless form. Pretty much useless form. We can't get any kind of information. Very limited. We can get, I want to be fair. We can get some information, but very limited information from this form. So what we do, and what we'll be doing in this section, and the 4 homework questions is, we will always turn it into a useful form. We call it vertex form. I call it useful form. And if you want to associate into this institute, I call it seed form, seed. You will see why I call it seed. Because seeds are useful, aren't they? You put them into ground, give them water and sunlight, they turn into tons of product, right? Not tons, but pounds of product. They're really useful. They are very fruitful. So I call this a very fruitful form. But what is the difference between these two? Not quite different though. Look, A still matched. A doesn't change. It's still in front. However, B and C are completely gone. They don't show up here. X, there used to be 2 spots with x's, one under square, one is single, no square at all. They are combined into single one here under a square together with a number. So kinda these two items are packed. You pack these under a square with a number associated to x. And there's another number on the very end after h. So B and C are gone. H and K replaces them kinda. H shows up right after x under the square. K is on the very end. It can be positive, it can be negative. Sometimes this can be negative. Okay? Do you see the difference, visual difference between seed form and standard form? Useless, useful. So when I give you an equation, you should call it useful or useless. Such as this one. Is this a useful or useless?
Useful.
Yes, because A, X, and a number packed under a square and another number. But this question is ready for what? Crop harvesting. It's ready for harvesting. It's already been grown. But this one is
Useless.
useless. This is still This is still in the package. You need to put it on the ground, make a seed out of it, okay? So useless, useless. This is an application question. So you don't even have a useless equation now. This is the worst. You don't even have a useless equation. I wish I had something. So you're gonna build everything here on that question. Okay. Now once you get the useful equation, forget the old one now. Let's make a fresh start. What can I read, harvest from this form? Oh, everything. Pretty much all you need is stuffed in here. First of all, you can find out this little dot here. Its locations is H and K. This is called vertex. I call it seed. The seed. And this is the seed. Okay. So why do I call it seed? It's like there is a seed and two branches popped up there, right? This is the seed and two roots popped up going down, okay? So this is where everything emerges from, starting value. So this is the start. So your function either goes up from the seed, like just the plants. Some plants have branches going up. Some plants go deeper down, like a root, okay? So you have two options, but what I care is where the seed is, so I can grow the plant. So that location can be read directly out of this equation. Look, all you need to do is take these two numbers, couple them, there you go. You know where your seed is. Second, this number in front tells you the orientation this graph has. Is it going upward direction or downward direction? It all depends on the sign of this number. If the number is positive number, you have this situation. If the number is negative, you have downward growing seed. Okay? Okay? Any questions so far? Now, there is a line that goes right through between these two branches. That line is called, what is it called?
Axis of symmetry.
Yeah, axis of symmetry. But how do you write it mathematically? You need to set it into x equal a number, and guess where do we get that number again? Go look up from here. You look up under what square, what number you have, you set it into x, there you go. That line, axis of symmetry, is that equation. And when you fold the curve along this line, those two branches overlap, okay? And these two as well. There is a line of symmetry right between the branches. It's hidden right here again. All right, that's it. You know everything you need to. Once you are given this useful equation, you can get all this data in this question. 8 parts. There are 8 parts. So these questions are substantial. So these questions worth a lot in the test as well, because it has 8 parts. But if you mess up the first step, which has already been done for you here, but in the next question you need to do it. You need to get this useful form on your own. All parts will be wrong. So you need to go slow down, double check your work. Okay? Alright, so what are we doing first? There is a quadratic function given in seed form, vertex form. We just need to harvest it. And in part A, you just need to tell me whether the graph is like this or like that. Is the U shape, upside down U shape? How can you tell in part A?
Upside down.
It's upside down. Why?
There's a negative A value.
Right. A is negative, so it implies upside down. So it's this choice I will clean, say, inverts, that's enough. So A is -2 less than 0, so the graph opens upward. Okay? Alright. It's a lot easier in your homework. You just need to go choose one option. You don't have to type. Oops. Why did I say upward? Okay, sorry. Downward. Alright, it's too late. I missed already one part. Try to get partial credit. Okay. So you have, again, be careful what you type in. You have only one shot in 50 true or false questions, okay? Second part, we are going after the seed. Where is the seed? So I can plant it and branch up or down in this case. Where is it? That's tricky a little bit. Raise hand if you know it. Right. Identify the vertex. That means coordinates. You need to write 2 coordinates of this thing. That's it. All you need to do is read 2 numbers for me, please. I know it's not this. It's already been used up. Well, you're down to 1, 2, 3 options, and 2 of them is the right choice. Alright, raise hand so I can give you credit. Yes.
-2 and 8.
-2 and 8. That was a trap. Sorry. Because I know you were going to do this. Jay?
Would it be 4?
4?
Yeah, plus 4 if you make
Okay.
it 2 squared.
What is the other component? What is the other one? 8?
8.
Okay. Any third answer?
Positive 2 and 8.
Positive 2 and 8. We've done this in 1075, right? Okay. You see, it pays off to listen to my classes sometimes. Yeah, 2, 8, -2, 8, 4, 8. Any fourth answer? Okay. Alright. Alright, here's the trick. I didn't tell you the whole story. You see, this was a negative each, but they only took this without the sign. Kind of it's positive each they took. If you don't see a sign, it's positive each. That means no matter what you have here, you're taking opposite of it. So just take a look at what number you see here. -2, then you must take positive 2. Okay? You don't have to square it, Jay. I know your reasoning, you want to square it. No, it's just the number right there with opposite sign. Okay? Alright? Make sense? What if this would be a positive? What if you see a positive sign?
I would take negative 2.
Yes, you will take -2, 8 then. You will take this answer. But it's not. Alright, so let's leave the right answer on here. Let's go to step 3. Determine the x-intercepts. Interesting. I didn't talk about this, but because how did we find x-intercepts in this class so far? There was a method I taught you way back a couple of weeks ago. How do you guys find x-intercepts for any function? Where x-intercepts are the locations your graph crosses x-axis. Locational locations. How do you find it? What? Yeah, we always set the other opposite variable 0. So it's not any different here. It's not any different in this question. All you need to do is set y into 0. Can I continue here? More space. So see, I will set y into 0. I don't see any y. Where is y? It's this. G of x is y. So I set it into 0. It's not 8. Oh, come on. Minus 2x minus 2 squared plus 8. Alright, we need to solve for x now. How? Solve for x, how? Oh, we need to square this, FOIL it, multiply by minus 2 plus 8. Shall we do that? It's a good idea, right? If you want to solve something, you need to get to the full squares, so I will just multiply this out, right? If you multiply this thing out or this thing out, you spoil something beautiful. You ruin something beautiful. This is seed form. If you extend out this square and multiply out everything, you get the useless form. This form you get, and that ruins our questions. Don't mess up the square. Instead, just focus on what your target is. My target is to get to x alone. Solve means get x alone. All you need to do is get rid of 1, 2, 3, 4 numbers one by one. Kill 4 guys one by one. Who do you stop with? You have 4 targets. You're a sniper. The one that's furthest away from my target, you don't want to wake up everybody. You want to kill the one who's away from the group, right? Kill 8 first. Alright. Negative 8 equals negative 8 equals negative 2. So who's next?
Divided by negative 2.
Yeah, I will attack this guy before this because this has a guard, x, and this has a guard. I will take this away. So we divide by negative 2. And then this guy turns into
4.
just 4. Alright, what is next?
The square root of those.
Yeah, before this guy, I will take care of the guard, which is taking a square root. And there is a danger. Don't step on the mine. There is a booby trap.
Negative plus or minus.
Yeah, that's important. At this stage, you need to put, when you take a square root of both sides in an equation solving question, you must put plus and minus where? Which side? It really doesn't matter, but it's just convenient to put it on the number side. And compute that square root if possible. Can you compute square root 4? What is it? Plus minus 2 equals x minus 2. These two cancel. Alright, we're almost there. Just to get x by itself, I need the final move, which is add 2, right? Now we have x as 2 plus minus 2. But I need to compute this. How do you compute this? 2 plus minus 2, what does that mean? You need to first take one option and compute x. And then take the other option. So x is either, I'm taking the first positive option, 4, or x is, take the negative option, x is 0. Congratulations, you just found 2 intercepts which are 4 something, 0 something. What is that something?
Here.
You got these 2 numbers down, okay, but what is the second coordinate? It's y equals 0, so you have everything complete now. Okay? Alright, we're almost halfway through. So much work. D. Alright, this is easy. Part D, find y-intercept. You know what to do. For y-intercept, you set who to 0? X equals 0 in G, which is minus 2x minus 2 squared plus 8, negative 8 or plus 8? Plus 8. So enter 0 in here and we are all set. So easy. 0 minus 2 is minus 2 squared 4, double it 8, minus 8 and plus 8 is 0. Actually, I already knew it before even I start this part. Huh? If you end up x-intercept as origin, this is origin, right? Isn't origin the meeting point of x and y? Origin is also y-intercept. Origin is both intercepts actually, x and y-intercept. So if you get origin in one case, the other one is automatically y-intercept as well. I did it anyways to show you. E, any questions? By the way, you need to make a couple. 0, 0 is the intercept again. E, what is E? Sketch the graph. Finally, all this information gathered can be used for something useful. You can make the graph of that shape, either U-shape or upside down U-shape. So we start with the seed. Where is the seed? 2, 8 was the seed, right? Yeah, find out 2, 8. All right, I'm gonna say this is 2. If this is 2, let's go with 2, 4, 6, 8. And meet them. This is your seed. How is your plant growing? Which direction is it growing from this seed? Downward, right? Upward? It was downward, right? So you need to let it grow downward, but you have options. I can let it grow really wide open, or I can let it grow skinny. How do I know which way? Is it skinny? Actually, that minus 2 in front tells me how skinny it is. If this is less than 1, it's really wide open. It's more than 1, like 2, it's skinnier. But I need to be precise. So why don't we use x and y intercepts for this? So it's going to tell me where this is going to cross. At 4, I think this is much better. We have 4 and 0 as xy intercepts. So the second option is a better one. Okay? Something like this. Alright, but in the homework you get to pick the right choice, but don't cheat on the computer options. Just do your handwork and then pick the right choice. Alright, are we ready for EF? Any questions so far? I get the seed first, choose the direction, let it expand, grow, and make sure you visit those points you found already, and you're good. Alright, what is in E? We did that part. F, determine the axis of symmetry. Axis of symmetry is x equals set some number. How do I find that number? See, axis of symmetry is x equal h. H is the number that's showing up next to x. In other words, h is the number in x coordinate of the vertex. So I need to just take the number in the x coordinate of the vertex. There you go, 2. And you can even show that here. You can even actually see that. Here is that line going to right at 2. Okay? Alright? G. I think this is the last part. No, there is H. Okay. Maximum or minimum, and then domain and range. Okay. Quadratic functions have either max or min, not both. Okay, depending on the shape. If it's a regular U shape will have a minimum. Upside down U shape is a maximum. So what do you expect to have on this question? Maximum, because it's upside down. Now how do I find this maximum value though? Oh, look where it is. It says K here. It's the second coordinate of the word seed again. That useful form seed is paying off again. Second coordinate is the maximum value. Here you go. It's 8. 8 is maximum, but it happens at, this is the max value. If they ask me where is it happening, what x value happens, you're going to say this, at x equals 2. X coordinate 2, it happens. But the value, how high that mountain is, if you want to measure the height of the mountain, it's 8 feet above the ground. Okay? Write the domain and the range. And please, for domain and range questions, refer to the graph. It's a lot easier if you go with the graph. Domain means when you push this picture down and from both sides, up and down, smash it to x-axis, it's the image you get on x. Actually, we all know quadratic functions always have the same domain. What do you see that domain is? Imagine these sides, these are widening. These branches are opening wider and wider. Eventually it will go all the way to the left and right on the very deep end. Yeah. It's going to cover all these points on x-axis. So domain is x values, possible x values you enter and get the function value is negative infinity to infinity. How about the range? Range is obtained, this y values, list of all y values. It can be seen on the picture if you compress it from the sides and push it to the y-axis. Push this blue picture to y-axis. What interval do you create? Yep. Sorry for the poor picture, but I did my best. The peak point maximum, these points rise, these blue points rise maximum here. So this is the cutoff, and you have everything else underneath it. All these points created by the blue points, because these branches go down and create this, except maximum is 8. And do we count 8 in or out? Is 8 included in this green region? Yes, because this peak point makes it, right? So we are going to cover everything from 8 to negative infinity. So range is positive 8 to negative infinity. Oh, this is included, so I will use a bracket. Am I right?
You want to put it,
Hmm?
you want to have the smallest value.
Yes. In an interval answer, you cannot have the right numbers less than the left or left bigger than the right. Impossible. This number should be small, this number should be big. This is impossible. 8, 9, 10, how can you go to negative infinity? Impossible. So when you're reading range values, you read from bottom to top. Negative 8 to negative infinity to 8. Okay? Alright, this completes the question. Long, lengthy procedure. But any questions? So take a moment to digest. Look at all the parts we've done. It's a little bit mixed work out everywhere. I'm using the past work to do the later work, parts, but questions? You good? All right, let's quickly go through this and help me, please, because I don't have the data. 2, 8, right? This is it. Has 2 intercepts we got. And they will ask these intercepts, I bet. You can put them in any order, 0, 0, 4, 0 were they? All right, y-intercept were 0 again. And the picture was 8, maximum 8, right? And going down at 0 and 4, this is the one, 8. Axis of symmetry is x equals whatever the h was, which is 2, right? Has max or min? Max. Maximum value we found was 2. Well, it was at 2, but the value was 8. It's asking for value. Domain is, for any question in this section, is always negative infinity to infinity. Everybody can be used, substituted in x. But the range varies from a function to another. Negative infinity to 8. All right, we're done with the easy one, except the first part. Any questions? Last roll? No? All right, we're going, I think we're skipping one of them. No, we're doing everything, okay. Number 2. Okay, this one is the mother function problem here, because they didn't give you the useful form. Vertex form is not known yet. You're gonna make it in step 1. Look, you have to start with that. Vertex form, get the vertex form. Well, this one is the one, this part is the, again, essential part of the solution, and most widely mistakes happen here. So be careful, watch my steps closely. Alright, so we start with, this procedure called completing into square. Completing into square. That process, packing, I said packing these x's under the same square is called completing into square technically. So that's what we are gonna do. First off, you're gonna check out if this number is 1 or not. If it is 1, you don't have to do anything. You can skip first 2 steps, but is it 1? No? This is the step you're gonna make. You are gonna factor out that number from these 2 only, not this one. This is kinda in second place. It just keeps going on to until the very end, and we just use it on the very end. Everything is happening between these guys. So I factor 3 out from these 2. And you will tell me what happens to these 2. Only 3 out. Don't factor out x. X is common as well, but we don't factor x's. X's, leave them alone. So what is left? It's x squared and minus 6, right? And where's 23? It's out of the picture again. 23 is not in the game. It's on the sideline waiting for his turn. Okay? So far, not big change. Okay, next. I'm doing this next move. What did I do?
Should this square be on the outside of parentheses? Or no?
No, not yet. Not yet. Still square. We're not done yet. When we are done, yeah, it will pop up outside. But right now, it's still inside. What did I do?
Left a big space.
Hmm?
Left a big space.
Yeah, I just made a big space here. So you can guess what's coming here. I'm going to put something here artificial. I choose, I made up, and put something, anything I wish. What number you want to put in here? 100? No, it's not our choice. We need to compute it. Okay, here is what we are going to do. We are going to find out a number here, and they are going to make a triple here, 3-term. That 3-term must be expansion of the square, special square. So I'm first doing the next step before doing this to see what that square will be, and then I'm going to choose this number. I'm telling you what that square will be. It will be x and a number squared, and this number, when you square it, it needs to meet -6. So here is the steps you need to make. You're going to find out this number from this number in the middle here. And once you find this out, you're going to put into this space somehow. So it's kind of a very weird steps, okay? Usually you do this step and go here, but no. In your mind, you first visualize what this pack into, and what that pack into is this found by this number. And then from this expansion, you will figure out what to insert here. Okay, let me ask this. What number, once you square, makes x squared minus 6x and something else? But I want to meet minus 6x for sure. What number, once you square, makes that? You can take a couple of shots. I mean, you don't have to get it in your first shot. Like, give it a shot with +1, for example. When you square this, it's, by the way, x plus 1 times x plus 1, right? When you square this, FOIL it, you get x times x squared. X times 1 is x. And 1 times x is another x. And 1 times 1 is 1. And you combine this, and it makes 2x. Nope, sorry. 1 didn't work, because you only made 2 instead of -6. Doesn't work, guys. I bet this needs to be a negative number. Because if I choose this to be negative, these will turn negative. I'm closer. At least I match the negative sign now. Cool. But this number is too small to produce 6. What do you think you need to go with here? Negative 3. How did you find it out? Before multiplying this. Negative 3x makes negative 6x, and voila, I hit these two here. How can, next time, how can we find this negative 3 without this struggle? I don't want to waste time here. I want to look at this, stare at this, and decide, oh, this is negative 3, like that. Yeah?
586 by 2.
Yeah, take half of this number, half. Negative 6, half is negative 3. Keep the sign the same. Okay, going back to here. We can't do this. We can't. Because when I square x minus 3, you also get, by the way, this is 9. You also need a third number. It's not here. Look, this converting into this is wrong, because I don't have a third number. That's why I kept the space here, because I'm going to add manually that number so all three can collapse into this thing. What is that number? So you already know it, yeah?
Positive 9.
It's positive 9, but if I covered this up, assume you never done this. From here, could you find it? From here to there. Square of this number, yes. Just take, first, look, again, these are the steps you need to do. Take half of this number, put it here, square it and put it there. Square and put there. So I'm going to add 9 here, so that when I FOIL this, I can match it. However, as I told you, this is my contribution. This wasn't in the equation. You see, there wasn't a 9 here. I put it artificially. I manipulated this equation. It's no longer the same as earlier. This is wrong. They don't match. I made this up. I have to take it back. I have to take this 9 back. But I don't want to take it back here. I want to make this guy here. Where can I take this 9 back? I'm going to take it back here. I'm going to charge 23 for this change. But is this 9 the correct figure? I put 9 here and subtracting here. So am I kind of compensating for this change? Fully? Does it make sense? Alright, let me tell you what I'm doing. I figured that I needed a 9. I'm putting a 9 here and subtracting a 9 from end. So I'm assuming they are canceling, so I'm good. Am I really good? What is wrong? Where my calculations, my logic has a flaw? Where?
9 is being multiplied by 3.
Yeah. When you guys add a 9 here, you're actually adding 3 times 9, 27 to this equation. You're adding 27. And just subtracting 9 is not going to make it. You're short. So you shouldn't be taking this number as it is. You should foresee what this multiply with that and then take it away. So this minus 9 is false. It has to be instead minus 27. Now we're good. 3 times 9, positive 27. Take away negative 27. It's still the same equation above. Alright. Now, did you get this? Because I'm going to explain this once. I won't be doing this anymore. Here is the fast forward version. Fast forward version. In a question like this, I explained to you how we're doing this. This is how I'm going to do fast. I was at the stage determining this, right? This is what should be going on with in your mind. What should I be adding here? Okay. Take minus 6. Take half of it, put it in your mind. What is half of minus 6? Negative 3. Square and put it here. 9. Multiply 9 with this and subtract from here. Everything I explained in 10 minutes, I did it in 1 second. You should be doing this way. Do you get it? Take the number here. Half and square is what I did. Take half and put a square to it. Multiply by 3 and subtract the result from the end. Next, why did we do this trinomial work? Because my purpose is to make this a square. Now it's a square. Next thing is a square. You need to just figure out what number comes here. We already know it, which is minus 3 already. Half of this number comes here. Half. Again, verify. When you FOIL it, do you get this x squared minus 3x plus 9? Yeah, it does. Well, what happens to this poor guy now? He pays the bill and gets reduced to negative 4. Okay? Done. What is this called? If x is under a square with a number preceding it and a number following it, this is called vertex form or seed form. Valuable, useful form. Okay? Any questions? The most important part of the question. If you get one of these wrong, a lot of steps will mess up later. Okay, before going to the harvesting, why don't you guys change this into vertex form quickly, this one. Let's see who's gonna do it first and fastest. Vertex form of the next question. What's taking so long? It's not as easy as it looks, right? Yeah, this proves that necessity of practice. This is okay. You need to practice so you feel the pressure. Did you get it? Anyone? Say it if you know it.
Three parentheses, x plus 6.25.
Hold on. What is the number in front?
3
3. And
x plus 6.25
and
minus 5.5.
minus 5.5. That's why you've been struggling now. Maybe it's decimals, a lot of decimals. I don't know. Okay. How many of you guys got this answer? One. Maybe it's wrong. Any different answers you got? Anything different? Tell me. If your answer is right, I'll give you a reward.
I got 3 parentheses, x plus 2.5, x squared, minus 16.75.
X plus 2.5
Yeah,
minus
16.75.
16.75.
75.
Alright? And your third answer? Hmm?
I got that one.
You got this one? Any different? Oh, we're almost out of time. Let's do it instead. Okay? First, we bring this number out front by factoring from the first 2 terms only. Don't touch to the number on the end. It's just 2. So I factor 3. This is x squared and 5th. No, it's just 5th, right? 5. Then we keep a space after 5x so that we can bring in a number and take out another number from the end. So what that number will be? It's going to be a plus what? Half of this number and square it. So half of 5 is 2.5. When I square it, it's 6.25. Looks like you got that idea, 6.25 from here, huh? Okay. But I need to take off some value so I can compensate for this addition. What am I subtracting on that?
18.75.
Yeah, you multiply these two. 3 times 6 is 18. And 3 times a quarter is 75. So we are on the right track. But when you make a square out of these 3 terms, it's not x plus 625 squared. It's not this number. We take which number? Half of this guy, 2.5. Half. Here, half n squared. And this is 1675. Good job. Okay? Alright, when you come back on Monday, please work ahead these questions. You're ready to finish this homework. We will quickly finish the remaining parts, and I'll give you a formula method next.
We're good at doing.
I'm sorry, come again?
So you want me to do 1 and 2 homework?
You can do all 3 actually.
3?
Yeah.
First 3?
You can
We're gonna
do 3, but I'm gonna give you an alternative method to find vertex from in 3.
Okay, so.
But regular method works 3 for 3 as well.
Okay. Understood.
No, you don't. You don't understand anything.